All right, so 8.7 today is on quadrilaterals and their areas. All right, so quadrilaterals. All right, what is a quadrilateral? I can't even say it. Quadrilateral. Okay, so quad, first part, signifies four. Laterals are going to be like sides. So it's a closed plane figure. It's closed, and it's a figure with four sides that are line segments. Okay, so let's take a look at some special, I call them quads so I don't have to write the whole thing out. Special quads, and then I'll show you a diagram. So the first one, let's take a look. I have a trapezoid. Okay, it looks like a trap. You're trapping an animal or something. Trapezoid, it has exactly one pair of parallel sides, and that's what those little arrows mean. These two are parallel. If there's only two lines that are parallel and it's closed up like this, it's called a trapezoid. All right. Next one, it's called a parallelogram. Parallelogram. It just means that two of the opposite sides are parallel and the other two are also parallel. So if that's true, it's called a parallelogram. All right, now we're going to get a little bit more specific. Now, if a quadrilateral has four sides and all the sides are equal length, it's considered a rhombus. Okay, that's the bigger outside view of it all. So that's a rhombus. And then more specifically, if you have something that's a quadrilateral that's parallel, so it's a parallelogram, right? Parallel here, but also has four right angles, that's going to be considered a rectangle. And then last but not least is the most specific of all quadrilaterals, which is a square. It's a parallelogram, okay, parallel on these two sides. It has four right angles, and like a rhombus, it has four congruent sides, and so that would be considered a square. Okay, all right. So add that to your notes, and I have a little bit more here for you. Next thing you need to know is that a quadrilateral can be cut in half to make a triangle. All right, just like this one right here. This could be a quadrilateral. It's four-sided. I just made them separately so you could see that. 1, 2, 3, 4. I can cut it in half and make two triangles. And since triangles have 180 degrees, that should tell me that a quadrilateral has double that, which is 360 degrees. Right? Think about it. If I come back to this square here, 90 plus 90 plus 90 plus 90, well, 9 times 4 is 36. Add a 0. That's 360 degrees here. Okay? So same thing is true over here. All right, so there's a key concept, the area of a parallelogram. Okay, so the area of a parallelogram is the product of the base and the height. This is stuff that you learned in elementary school, right? Area equals base times height. So the base times the height, otherwise known as the altitude. All right, so 3 times 5 would give me 15 centimeters squared. Last part of your notes talks about the area of a trapezoid. So you want to write this one down. All right, so the area of a trapezoid is half the product of the sum of each base and the height. What do I mean by that? Well, the trapezoid, if you flip it upside down, there's two different bases. There's this base or there's this base. So what you do is you take this base, add the other base, cut it in half, multiply by 3. And hopefully tomorrow in class we can talk about why that is. But in this example, I would take 4 plus 8, that's right here, times it by half, and also times it by 3, which is the height. So half of 12 is 6. 6 times 3 is 18. 18 meters squared because it's area. All right, make sure you have that in your notes, and then we'll do some examples here next.